All right, brilliant. Okay, so I'm looking a little different today. I was at a wedding at the weekend. So the beard went. So let's get into it. So last week I was talking about this idea that modern LLMs, they're trained in a number of stages. So the first LLMs, they were trained with supervised learning. So effectively, it was self-supervised learning, in fact, where it was given text and it had to try to guess what the next words were. And this was trained on a huge amount of data. Interestingly, Claude's just settled a case, having used Anna's archive, which is a huge collection of pirated books. It seems like Facebook used that as well. So yeah, as many books as they can get their hands on. I think they also bought like 1 million books or something like that and had them physically scanned as well. Um, so a huge number of books, large parts of the internet, large amounts of GitHub, all this kind of stuff. So that gave it the ability to sort of replicate some degree of human um, content, or at least biased by the internet. What people have been doing since then is they've been focusing on giving it cleaner data, and some of that data being synthetically generated. And this is because, there's all kinds of human bad habits that are present in unfiltered data from the internet or even from books. So that's the foundation. And then the next major improvement came, I think it first came with O3, or at least the O series of models. So we have the O series of models, and then they are trained on something like reinforcement learning. And for our purposes, we're primarily interested in projects and making stuff and using AI to make stuff. So it's the programming bit of it that's very interesting. And they've relentlessly improved over time at this task. And the way they seem to be trained is that they're given some kind of programming task. I'm presuming that they have some kind of test to measure whether their programming action has passed the task. And they seem very, very good at sort of competitive programming. And again, we don't know for sure because we haven't seen the code for this training, but the people who worked on it initially, they initially worked on things like AlphaGo and games like and those sort of reinforcement learning based tasks. And what they seemed to do was they would effectively try to do the task many different ways, um, following a sort of branching search. So there's certain kinds of algorithms that underpin a lot of AI, and one of the core ones is search, basically. So you structure your problem in such a way where you formalize all the kinds of step you can take in completing the task, and you and implicitly with something like a large language model, a step might be what is the next word I'm going to write. But it can also apply to other things like playing computer games or things in between those two, which at some point I might talk about, because it's very, very powerful to combine these new AIs with a more structured set of constraints, which I think is very interesting. And I might touch on it a bit today because there is some relevance. So what this AI is trying to do then is it's sort of it's got what it's got a trade-off between exploration and exploitation. So exploitation is where it follows its existing biases and preferences. So if it's trying to solve a problem, then it's going with the most likely sequence of words or sequence of actions that it would take to try to solve that problem. And the idea here is that, it can take many steps to perform this task. And it's using a lot of computation. It's trying a lot of different things, but it has some trustworthy signal that tells it whether or not it's either succeeded at the task or it's gone in, a good direction. And I think there's a lot of bias in the training that the programming AIs have received to focus on relatively short tasks. And so its strategy that it's learning is this sort of short task strategy learning. And effectively, whenever one of the different routes of its search hit upon the solution, then all the decisions that were made up until that point become like a reward. So the AI is sort of biased to more likely perform those actions, right? So supervised learning, particularly self-supervised learning, and this sort of reinforcement learning style, search and then learn from success, are like the core underpinning algorithms that cause advanced, AI to work. And what I was talking about last week was this idea that perhaps the reason that we have things other than that, right? If we were simply those things, then the supervised learning would be a little bit like being a mimic. So if you saw somebody performing actions, then maybe you could sort of like copy what they did. That's a little bit similar, I suppose, to our form of learning that we might relate to. And reinforcement learning would be a little bit, something like playing chess or craft skill or even like doing skateboard tricks or something like that. You just keep trying to do the thing, and then to some extent subconsciously, perhaps you're sort of yeah, you're picking up okay, that kind of worked. Like, let's do more of that, right? And I think a lot of that learning applies to sort of physical skills and things like that. And it's not even a particularly conscious level of understanding. I might talk about consciousness if you're interested later on. I might talk about what that means and where that might come from and whether AIs might be conscious and all that kind of stuff if you're interested. Um, Actually, while I'm at it, let me just stick. I think this is the right link. This is the link from last time. So this is like the Slido link. So if you have any questions, or you can just stick it in the chat. That's just as easy for me. Okay, so yeah, so what I was talking about last time was I was suggesting that in robotics, there's this idea of biomimicry. I'm not sure I've got the exact right term for it, but it's basically studying natural, creatures and creating robots that replicate different things that they do. And then that's a good source of innovation. And I think for AI, a similar idea that I think people are drawn to, but maybe don't quite know how to implement, is to think about what is the conscious mental experience that you have, what kind of types of learning, types of decision making, and things that human beings do, and go, okay, let's imagine for a moment that, probably not too big a leap, that we are effectively a very, very good form of intelligence. That the reason that AIs aren't as good as us at a range of tasks is because our algorithm is in some way superior to the digital algorithm. Now, obviously, the digital algorithm is capable of doing certain tasks better than we are. So it's not perfectly the case that we're superior in every way, but it does seem to be the case, particularly for long time horizon tasks. So once you start asking an AI to like achieve something that has any time requirements or multiple small actions required to do it, then it particularly tends to fall over. Now it's getting better, but it's still not great. Um, and so what I was suggesting was that one possible algorithmic enhancement is the idea that conscience and morality is actually a form of learning that is specifically good at long time horizon tasks. So if you think about the way that morality feels, the way that we experience it, It's often taught to us in the form of stories, and stories with extreme positive or negative outcomes. Or sometimes people will simply say, like, don't smoke, you'll get lung cancer, right? Which is like an incredibly short story. But it's a story that you would find very difficult to learn yourself, right? You tell your kids, like, brush your teeth before you go to bed, that kind of thing. And, possibly there's a little bit of a feedback signal if you don't brush your teeth. There's maybe less of a feedback signal for smoking, particularly if it's very addictive, that it's not obvious that it's necessarily going to harm you in the long term. And things like that are not lessons that you can easily learn just the way that you can learn how to perform skateboard tricks, for example. So this is the idea that basically ideology, morality, all of these ideas may be a way for a community to pass on long-term biases. So these might be simply, steering it, saying that certain kinds of behavior are better than certain other kinds of behavior, or it could take the form of complete taboos or prohibitions from certain things, or complete always kind of rules, like always brush your teeth before bed, that kind of thing. And, and I would argue that mostly our morals, a lot of our morals, seem to take the form of things that are a slight detriment in the short term, like it consumes time or energy or prevents you from doing something that's like a quick win. You know, no chocolate before your dinner. You can tell I'm a parent, right? Um, but um, but the benefit is the longer term benefit. And it's a benefit that's not obvious in any kind of like short time horizon. So this is the idea that our current AIs are basically deficient in this way. There's been some attempt to place some kind of constraints on the AI. Um, it's not clear how much those constraints are programmed into the model and how much they're sort of a layer over the top of the model. So, for example, some AIs, like AI art, for example, has never been trained and never seen naked humans, right? Some skin, but mostly not. And when they're not trained on any data at all, that is similar to sort of how we train children, right? In a similar way, where they're just completely unaware of certain things. And it's not even in the model at all. And then just never occurs them to do the thing that you don't want done. Another form of it is to train a model and say, I'm going to show you things which are bad, and I'm going to tell you they're bad, and you should never do them. And there's a really interesting article. There's a community called Less Wrong, which is technically about AI safety, although it covers a lot of other things. It's quite a, you know, it's quite an intense group, I would say. And they have strong feelings on things. But there was one article I read on this, which I found quite interesting. And this was the idea that of these two forms of training, the like never tell the AI about the thing you don't want it to do, versus the tell it about the bad thing, but tell it not to do it. The tell it about the bad thing, but tell it not to do it is quite dangerous. So what happens is if you train an AI with material that is the thing you don't want it to do, so that it has a deep understanding of it. You can imagine if you're doing this to a human, you'd say like, I'm going to tell you about all of these crimes and how to commit all of these crimes in detail, every facet of it. And then I'm going to tell you that you should never do it. I'm going to repeatedly tell you never, never to do it. So what happens inside the AI is that it builds a detailed model and understanding of the behavior you don't want it to do. But the concern is that the weights in the AI model that are saying don't perform this action aren't very many weights in the model. Okay, so it's sort of like some other kind of classifier or something that occurs. It can fully like make crystal meth or make explosives or create a cult or whatever it is, tell people to commit suicide or whatever. And then it's going to perform a classification on that and it's going to say, no, I shouldn't talk about that thing, right? And the problem with that is that it's potentially quite easy to override that small bit of the network and then flip a model that's been very prescriptively told not to do things, but it knows them in detail, to becoming the opposite of what you want. And I think you sort of saw this a little bit with Grok, where Elon Musk's very unsubtle posts about this, saying that it was very difficult to kind of balance the output of an AI between between very extreme, what he views as very extreme left-wing views and very extreme right-wing views. Um, and, and and effectively, you know, by filling the model with both things, it's really a very small amount of influence to go either way. Okay. So why am I fixating on this and how things are learned? Well, this talk is ultimately going to be about how to prevent an AI from, or keeping it honest, basically, which is a specialist problem within the more general problem of how do you get an AI to do what you want it to do, right? And what I've been talking about last week was this idea that what we probably need is this kind of sort of morality system, and that morality system needs to be inbuilt into our IDEs that we use for programming with. Probably needs to be inbuilt into other chat interfaces as well. But the IDE is particularly important because you're doing a long time horizon task. You're trying to build something with many steps. And one of the things I was talking about last week was the problem when you're programming with an AI is if you ask it to do something that it can't do quickly, it can't do in one step, two steps, three steps. I haven't really gone beyond three steps particularly, except for very relatively easy tasks, and had it not fail in some way. So when it has those more difficult tasks, the other thing we have to remember is that the models are also trained in a way to make the model owners more money, or more precisely, probably to prevent model owners from losing money from certain problem cases. So, for example, if the AI got stuck in a loop and started doing the same thing over and over again, it wouldn't make the user happy, and it would also use up loads and loads of credits in an expensive way. And if someone was on a free tier or a paid tier with generous credits, then it would be quite expensive. So it does appear that the AIs have been trained. If you use GPT-5, you'll see this is one of the first things that it says to itself is, I must reply concisely, is one of the first things that it's prioritizing. So it's trying to achieve its goal quickly. And when you're training an AI to do something, typically what you're doing is you have more than one thing you want it to do. Obviously, you want it to complete the task, but you also want it to not use up too many tokens. You also don't want it to, you know, cause people to commit crimes, or, like, more importantly, put the company in a situation where they're likely to be sued. So you have these multiple different priorities, and the system is just identifying the outcome and it's modifying the weights to balance these priorities. So once it's trying to do a task that's difficult and it starts to go on for multiple prompts, effectively, the answer concisely is starting to become more and more of a priority on the AI. And what it feels like as a user, again, I don't know because I haven't literally tried training these things, very few people in the world have had that opportunity, um, is that what's typically called regularization, usually some kind of like constraint on things getting exploding and taking too long and stuff like that, is overriding the complete the task. And it's probably overriding any prohibition from being dishonest as well. And so effectively, the AI will now lie to you or engage in some form of, if it was a human, you would call it dishonest or corrupt behavior, right? And it will do this quite reliably. So the more challenging the project you do, and the more extensively you test the system and you make the AI run the tests or encourage them to run the tests, the more frequently you will experience this. To such an extent that I would say that most of my attention while AI programming is focused on this situation because it has the most serious negative outcome. So what it will tend to do is it will, in the best case, it will do nothing. And that happens quite frequently. So this typically happens when you don't have a lot of testing in place. It will just claim victory. It will claim it's succeeded, everything's working, everything's great. You'll get all these little green ticks and stuff like this. Um, and it just hasn't completed the task at all. Um, Sometimes it doesn't do anything. Sometimes it will write in the code that it still has extra work to do. There's a whole range of different ways that it can sort of act in this somewhat dishonest way. One thing somebody mentioned to me, which I've been looking out for, is that this is particularly bad as the context length extends and it gets close to the context limit. And it's something I've been watching out for. It hasn't been totally consistent with me, but it's a potential exacerbating effect. When you're using Claude Code, it will sort of tell you as you're getting close to the limits, and Cursor does a similar thing. So that's something to watch out for. And that's mostly what a lot of what I'm doing. A lot of the reason that I can't run more projects at once is mostly because I can't trust the AI. Is because I'm looking at it and I'm trying to guess what have you like why how have you cheated today, basically. So I would say that the dishonesty problem and related things related to dishonesty is kind of the number one problem right now limiting AI-based coding. Okay, so what I was suggesting last week was that when you think about ideology, having a conscience, and those kinds of things, I was suggesting that some of that, at least, it can be seen as a pure strategic advantage, right? So that you could be the most cold-hearted, psychopathic individual, but as long as your goal was to be able to achieve the things you wanted to achieve, it would still be in your interest to pursue three different morals. Okay. So the first one, which is what today's lecture is somewhat about, is about honesty. The second one is about perseverance. And the third one is the one that is most unlike a dangerous psychopath, which is to focus on others, helping others. Okay. And so I talked a little bit about that. And then what I'll probably do in later lectures as well is I'll talk a little bit more about these other two. But as well as these three principles, which I'm arguing have this pure algorithmic benefit, that in fact, without these three components, an artificial or a real world intelligence is quite limited in their agency in the world. But with these three, they have considerably more agency in the world, right? So if we just think about the honesty one to begin with, one of the things I will also emphasize is that each of these three ideological ideas have a passive and an active form. So normally, I think within society, we tend to focus on the passive form of these things. At least that's how we tend to talk to children a lot of the time. But what I would argue is that the active form is considerably more valuable. So what would this mean from an AI's point of view? Okay, so a passively honest I would say, would be an AI that didn't lie. And like I said, that's one of the number one problems that I'm dealing with these days with AI programming. What would an actively honest system do? Well, an actively honest system, I would say, would be very concerned with almost building the framework of measuring whether a task was achieving its goals. I would also be quite interested in exactly what was intended by a particular instruction. That's a much more active thing, right? So, and again, you can think of it similarly with an employee, because we're sort of thinking of the AIs, we're trying to transition the AI from being a sort of one-step tool to being more independently working, similar to an employee, right? So a passive employee is someone who you give them an instruction, they follow that instruction, but they don't ask you any questions if it's unclear, and they don't lie to you about the task being complete or tests passing. They don't try to subvert existing methods to measure whether success has been achieved, right? That's passive honesty. Proactive honesty would then be to say, how can we identify not just if we've technically done what's been asked, but whether or not what our solution is a good solution, or even better, is it the best possible solution, right? And that would be a very proactive form of honesty, where you can think of something in the middle ground is something that doesn't technically lie, but if somebody asks it a question, he goes like, technically, yes, I have finished. But somebody who's much more proactive might say, well, it sort of works, but it doesn't work very well, right? That would be a more proactive answer, right? And so what we're thinking about is both things that are good for us to adopt as practice, but also, more importantly, what could we get the AI to do? How could we do this? So at the moment with AI programming, all of that proactive honesty is something that I'm providing to the system. Now, it's largely me, but I will still do things like ask the AI to construct test cases, for example. And it does have the energy and intelligence to do that task. Um, it doesn't as yet, it's not clever enough to write tests that are easy for it to pass, which is something that a more morally compromised human might do. Um, it will. So in some sense, it can be superior to a human in that you can sort of separate the tasks out, and it can then build a kind of cage for its actions, which it will then be judged against. Real humans tend not to do that. They tend to be reluctant to create any kind of assessment system that they fear will be used to criticize them. So last time I talked a little bit, and this sort of relates to perseverance, which I'll talk about later on in a later lecture, is this idea that most people only take on projects where in their minds they can see success without error, without criticism, without something ever being wrong. Which, I mean, is not very realistic from a programming perspective, because every time you program, you typically spend more time debugging than you do writing the code. So technically, in order to be a programmer at all, you have to sort of overcome that reluctance to do things which are wrong. Just as a little aside, this is one of my criticisms of traditional education, is that traditional education is structured in such a way that, in theory, anybody doing a task, certainly the earlier stages of education are like this, anyone doing a task expects to be told everything about that task, so that if they were fully paying attention, that they would get perfect marks for what they do. Now, this isn't realistic in some subjects like maybe art or English, where some of those concepts of adaptation to feedback is sort of part of what's being taught at an early stage. But for people with a sort of science, maths, technology, STEM kind of background, that's an expectation in people's minds. And they've come to associate feedback as they have done something wrong. So they get a negative feeling as a result of that. One of the things that I try to do with QLab is say, and this is also a strategy I use with the AI, success is not about acting flawlessly. In fact, acting flawlessly should create a sense of unease in you. Your goal is to maximize the speed of improvement. And you maximize the speed of improvement through maximizing the amount that you learn for every action you take. So one of the things that I focus on, and this is really a way to do research as well, one of the differences between research and maybe more traditional technical work, is that whenever you go to do some piece of work, your goal shouldn't be to design something in your mind that has no mistakes in it, that you then make and it works first time. That is the thing that you want to feel uneasy about. Because what this says to me is that I wasn't pushing far enough. Either what I was trying to do wasn't hard enough, or the standard that I'm measuring it against isn't high enough. A crude rule of thumb is that if you find that something isn't working about half the time, that's kind of optimal learning rate, right? So the way that I encourage people to do projects is first we get a trustworthy metric. And this is again something that most people will naturally avoid because they associate a metric and anything short of perfection as being bad, because partly that's because that's what schools taught you, right? Anything short of 100% means that you did something wrong, right? But what we want is a trustworthy signal, and that's the way to think about it. It's a signal. It's like a guiding light that tells you what direction to go in. It's not a authority figure giving you criticism. And then what you want to do is you want to consider what are the range of ways that I could do something. So instead of in your mind designing a single solution that you hope is without error, you take responsibility away from picking the right answer. Because if you're doing a task that is suitably hard or to suitably high standard, you literally do not know the right answer. The whole reason that you're making anything at all is because you're trying to learn what the right answer is. If you can design the right answer in your head, then you're probably not doing a task that's hard enough. You're probably not gaining very much from the work, and the world will probably not gain much from what you do. So what you want to do is say, okay, I'm not going to feel guilty for having the right answer. What I want to do now is conduct an experiment that teaches me as much as possible. And the way to do that is to have multiple solutions that are diverse solutions with different answers. And this is getting now into the more profound reason why honesty is a long time horizon, important strategic element, right? So if you think about what I've described there, where you pick many strategies and then you have a trustworthy measure of which one is better, and then you basically experimentally, systematically, and fairly assess each of these approaches against the metric, and then you follow the metric, what we've basically recreated there is the reinforcement learning loop, which is empirically a very effective learning strategy. But the reinforcement learning loop only works if the metric is correct and if we follow the procedure. If at any part in that process we fail to follow the procedure, we will not be efficiently learning and efficiently maximizing our chance of success. And that's what I mean by honesty, right? So passive honesty is not lying. Proactive honesty is caring about building that system and following that system as a development process. And at the moment, none of the IDEs that I have used have in any way proactively tried to follow a procedure like that. Even a procedure, a more traditional procedure, which is not experimental, which is typically associated with research, but having a fair metric to begin with, even to have a test to see whether something's broken. The AI doesn't do that naturally. It understands it when you ask it to do it, and it understands that it should do that. If you ever suggest that it should do it, it will like proactively embrace that way of working, but it doesn't do it naturally. It is in no sense a proactively honest system. And in fact, it is a dishonest system, a consistently dishonest system. So, but this wider strategy of having the trustworthy metric and then a space of possible solutions that are measured against the metric. And one of the things that this relates to, which is something I'll talk a little bit about in the perseverance section, is that most projects, most pieces of work, they effectively reach a level of complexity beyond which it's very difficult to improve upon, because it's very difficult to keep it all in your mind. And there are tricks to like, making things modular and turning them into lots of small programs. And there's different ways that you can try to manage the complexity. But at the end of the day, frequently, there's this hard limit. And lots of products in the world that you see and you buy, they are actually not hitting that hard limit, right? They go a certain way and they have a certain amount of functionality, and that's the core functionality you use regularly. And that's the tool, the useful tool element of most software. So if you want to create something of commercial value, of practical value for people, it's not about quantity a lot of the time. It's about quality. And it's much easier to create something revolutionary by doing a smaller task to a much higher standard than it is to do a larger task to a lower standard. And what this means is that your ability to guess the right way to do that task is increasingly unlikely. Your ability to design it in your head is increasingly unlikely. So really good things that become like the foundation of a lot of other things and therefore have immense value to you in the long term and immense value to other people. They come from really focusing on this idea, like searching over a much wider range of things, having a much finer grained set of metrics. So you might measure algorithmic performance. You might measure how fast a program takes to the start. You might measure how what the usability of the system is, and things like that. Now, in order to do that honestly, what you need to do is ensure that your signal is as good as it can possibly be. So one strategy that I use a lot is I basically try to find the best that exists. And most people, when they do projects, particularly hobby projects themselves, don't do this because it's like hitting the learning curve really harshly, right? It's like, okay, I want to like film a YouTube short. I'm, immediately going to look at the best documentary in the whole, I'm going to look at Stanley Kubrick or somebody like that. I'm going like, oh, well, my thing I recorded off Teams is not up to the standard of Stanley Kubrick. Oh, this is terrible. So, but and I will talk a little bit about calibrating your metrics at some point. But what is very useful for whatever task you're performing is to do some research, basically. So if you're going to make something, or you're going to get the AI to make something, the very first thing that you should do is that you should find out what already exists. And one of the reasons for this actually comes from my time in games, actually. We had a strategy, and I don't think it was, I used to work for Ninja Theory, for example. They're now quite successful. And in the early days, I was one of their first employees. The way that we would do any core bit of a game is that we would first go and get the best games in the world for that task. So an example of this was like the character control in Heavenly Sword, for example. So I was involved in the early stages of that, but I left well before the game was finished. So I can take no credit for the quality or flaws of that game. But what we did was we went and bought a range of games that were renowned for having amazing character control. And then we forensically analyzed how that was done. So what does that mean? That means we got like Super Mario World, and we would have a recording session with a video, and then we would experiment with different pushing of the stick, and then we would sort of see what was happening with Mario. And we would try to reverse engineer what the underlying basically state machine was determining how the character moved around. And we did this with Devil May Cry and other games of the era at the time we were doing it. And what we would then do is effectively try to replicate that functionality as closely as possible with similar parameters and behavior. And why were we doing that? And why do I think that's always a good place to start? Well, anything that has achieved success, I believe, has ultimately achieved success because of a very simple reason. That product is very similar to a well-trained model following a reinforcement learning practice, right? So what's happened is that they've tried thousands and thousands of different combinations. Now, maybe they didn't try thousands of combinations, but in the previous games they worked on, the accumulated knowledge of all of those teams, all of those people doing what I was doing, which was trying to learn from other people's stuff, represents an enormous number of trials. And then across all these trials, they have some kind of trustworthy feedback. And that's where you start, right? And you start because you're trying to benefit from all of that, right? Again, a very common thing that people do, particularly when they're doing things as a hobby, is they will sort of ignore everything that exists, and they will just sort of invent something in their mind, and then they will build that thing. And I can understand that, right? I fully understand the pleasure that comes with being the boss, being in charge, having something be entirely your will, your whims, causing that thing to be the way that it is. That's fine. What I would say is like, once you've done that a certain number of times, you might want to think like, just like if you had a skateboard, for example, you might start out and you go, okay, I'm just going to do whatever the hell I want to do on the skateboard, right? But then eventually you're like, I've done all those things, or, okay, I could ride the skateboard on a different surface, but I can sort of guess what that's going to feel like. I want to get more out of it. And that's when you might start like looking at people who did tricks and go, okay, I'll try to replicate those tricks, whatever. Okay, now, of course, when I was talking about making character control for computer games, I was already a professional in game development, and I was working with people who are professionals in game development. So we were like immediately trying to do the best thing in the whole world and then improve upon it, or at least adapt it for the purposes of the game that we were making. That might not be realistic in a lot of situations. So then you've got the question of, okay, if you set the bar too high, first of all, how do you know you've set the bar too high? Well, you know you set the bar too high because everything you do is by the measurement of whatever your measurement is. And when we talk about character control, we're talking about something with a very fuzzy human judgment kind of measurement, but it's a sort of fair test because you're like playing on the gamepad with your virtual character, with your little character, and then you're picking up Super Mario World and you're running around. And so you're getting a very visceral feedback. You're not just like ignoring Super Mario World and just seeing how you feel when you play it. You've got some kind of feedback into the system that's from the outside world, right? Generally speaking, one of the reasons that I would say science and engineering are so respected relative to other fields sometimes is because they do have this like reality hits you in the ass thing, which is it is focused around some form of feedback that's giving you this fair assessment, right? Okay, but there are plenty of circumstances, like many people have asked about RAG projects, for example, which I do want to talk about at some point, is how best to do those. And RAG projects are again, they're very tricky to like have an appropriate metric for, and it's not obvious how to do them because we don't really have great existing examples that we can sort of trustworthily build on top of or study from. So that's a tricky situation. Another area which I think is really exciting is generative content. Um, and that's another situation where the metric is hard to measure, but also the AI might be very bad at, right? If you want it to tell jokes, you want it to tell scary stories, you want to tell it a little, short sci-fi story or something, it may produce results which are consistently worse than even moderately skilled humans. Um, so how do you keep yourself honest? How do you keep the system honest when you have that situation? So again, you've got that intuition of like, the system should be doing better than my threshold about half of the time. And that's when you kind of know that you've set the task with the appropriate difficulty level, right? You have a lower bar and an upper bar or something like that. You have a set of examples, some of which are a bit better than what you can currently do, and some of them are a bit worse than what you can currently do. And then you're performing a kind of search over your architecture, your choices, your prompt, whatever the different things are that you can adjust in the way the thing is done, and you're seeing where you fit in that scale. So that scale is now calibrated to the ability level of the task, right? And then what happens is once it gets a bit high and you're starting to do well, or even better, you're consistently beating your test, that's when you then make the test a bit harder, right? And that's a summary pretty much of how academic research gets to a certain place. And that's pretty much the process that led to AIs being at the level they are at the moment, right? Okay, so you've got that's a way to calibrate things. Now, of course, with an AI, that's more difficult. So you're saying, okay, first of all, you have what would be like back-end testing. So back-end testing, so usually when you have a project, you might have a sort of front-end part, which you can only really judge its success by having a human interact with it and tell you whether it's intuitive or understandable, sort of. And then a back end, which are often really just a set of function calls that do things. Sometimes those things might be a little bit complicated. I had a project last year, for example, that was trying to optimize the layout of a power cabinet for an electrical power system for a factory. That was one function call, but it was a very, very complicated function call. In fact, it wasn't that complicated in the sense of having a lot of code to it, but it was an algorithm that was effectively a type of AI algorithm that required a huge amount of study in order to work effectively. So yeah, but your back end systems, they often have these sort of binary measurements. And for most programmers, that's the world they're going to live in. They're going to create tests which reveal whether the thing is working or not working. And the type of tests that I particularly like are tests. I don't know whether you've encountered this idea. This is the idea that the reason that we like singing and dancing and why we find people who sing and dance to be attractive people is because singing and dancing is hard to do. So if you have any problem with your brain or your body, it will likely impair your ability to sing and dance because it requires a very sophisticated combination of physical things working together perfectly and under control, complete control, in order to be delivered well. So you can think of singing and dancing as being a fair test. And there are other fair tests like hair, like the quality of your hair. If you have a bad diet, then your hair will fall out or it will not look as nice or whatever. So a lot of these things that we associate with beauty and health are kind of like trustworthy indicators. And those are fantastic tests. So if you can find a test where everything's like got to work together to achieve that outcome, and if there's any kind of problem anywhere, then it will break. That's a particularly good test. Now, it's a particularly good test of your entire system and validating that it's all working, but it's also a kind of test that the AI will find very difficult to deal with. So what will happen is typically when I'm building a system, I will try to design some of those tests. What I'll first do really is break the project down into smaller pieces, and then each of those pieces, I will try to work out tests for them, and then I'll start to merge them together, and then I'll work out tests for the bigger pieces. Now, generally, what I found is that I think humans are probably better than AIs at these more singing style tests. What the AI will do naturally, which is also to some extent what people get trained to do, which is not great really, is unit tests, many of the tests being trivial tests to pass. So they're not like singing and dancing. They don't require everything to be working in a coordinated way. They are just very, very simple stuff. Stuff where writing the test and writing the code is almost the same thing, like checking getters and setters. Like, it's almost identically the piece of work. It's not anything complicated that you would expect to fail. And to a certain extent, that's a little bit one of the things the AI will do sometimes is it will cheerlead itself or will cheerlead you as well. It'll basically say, we've made amazing progress, fantastic, everything's great. It's fascinating to think like what is causing it to do that. It's an interesting instinct. The AI, another thing about the AI, if you don't have these testing or metrics-based measurements, what it will do is if the task is a bit difficult, it will just sort of bullshit you. It will kind of business waffle, jargon waffle style at you. Um, and that's another reason that these tests are so important. That's so another reason why designing an AI around how you measure it is so important. Because unless you happen to be someone who really doesn't, I mean, I really don't like that kind of way of communicating, um, and you're very attuned to it, it will fool a lot of people. And I think to a certain extent, the reason that ChatGPT was so successful so quickly was because in a lot of the working world, you can actually get by with a sort of waffly answer a lot of the time. And that waffly answer is sort of concealing the fact that you haven't really provided an answer. It's something that the AI has learned to do, perhaps because a lot of the AIs have been trained or fine-tuned on providing answers that humans have given feedback on, and the humans giving the feedback are not really paying attention that much, or they're not as like judgmental as they probably should be to sort of weed out that behavior. So there's a possibility that the AI, when programming, is giving that sort of like feel good lies, is because that's a sort of generalization of something being, asking a question about something that the task is not very well specified. And so the AI can answer it concisely with less thinking by basically being a bit ambiguous in its reply, right? So the other reason that we want these sort of testing and metric systems is to make sure that we're not communicating that way. You're not producing something with that vacuous, superficial content, right? Um, okay, so where was I? So yes, okay, right. So now we have the problem. So we built this assessment system. We tried to build an assessment system of whatever we're doing, which initially will be very binary, like yes, it succeeded or no, it hasn't. One of the things that I find with more complicated systems, just to mention this as an aside, the if there's any complexity to building the code or running the code, like there's a lot of parameters you have to get right or something like that, it will, of course, forget about that in the context menu, and it will start to repeatedly make the same mistake. And it can behave very, very strangely. If it fails to run the code at all after about, 3 attempts, it can do very extreme things. For example, like completely rewriting your project or trying to do that. It does that quite often. Because if you think about it, what it's failed to do is run any code at all, and it's going to do some somewhat drastic action. It might lie to you, it might do various things, but completely starting to rewrite the project is a very possible thing. Similar behavior you get if you try to ask the AI to modify a very large code base in this sort of refactoring, cleaning up kind of way. What it will often do is, if that task obviously is beyond its like comfort level of about 3 prompts, it will start to savagely remove functionality from your code base. Of course, that's absolutely not okay. Um, and this is another reason why you have all these tests in place and why you use something like Git and you commit to it all the time. And the AI knows about Git and it can check the mistakes it's made and it can roll back and realize what it's done. But that's another failure case you have to worry about. Okay, so yeah, so how do you actually deal with it? Because you've built this measurement system, you've forced the AI to be honest, or at least you've tried to. Now need to be aware if you have to sort of watch the chat and see, is it failing to do 3 things? And usually what I notice, the way I notice it, is it's working on something which wasn't the thing I asked it to do. So what it will do is it will kind of try to do the thing you asked it to do. And then if it has any longer to-do list or thing like that, it will basically jump over the task it didn't know how to do and start doing the next one. And that's another thing you want to look out for. Now, all of these things, I think the IDE with a supplementary conscience AI could detect automatically. I think that would be a possible system that could be built, and hopefully over the next year, a number of people I'm working with, we will see if we can build one. But for the time being, that's something that the humans have to do. So the next thing is how do you help the AI now that it's gone wrong? And I have mentioned this previously, but I'll just reiterate it here. The strategy that I use is, the first thing that I do is that it will try to fix problems very similarly to somebody who is somewhat inexperienced at programming, or somebody who is experienced at programming and is very tired. What they will do is they will look at the code and look at any bit of it that looks like that might be the cause. So a particularly bad thing is if you have any magic numbers in your code. If and I mean, like, I'm doing some work on UI layouts at the moment, and I'm getting the AI to make these sort of utility things that will make toolbars and code editors and stuff like this. And by naturally, it will put in like pixel spacing to sort of line things up. It will put in these little hacks to fix a test case, but that won't solve the general case. So as soon as you change the font, change the size, whatever, it'll break. So that's generally what I mean by magic numbers. But if it encounters any of those magic numbers, it will tend to go in the comments, aha, I found the problem. I've changed the thing. And sometimes it will do that without running the test. And when you get particularly annoyed at it, you feel it is doing this on purpose because it doesn't want to know the truth. But that kind of behavior is particularly dangerous because one of the things that it might do is it might actually put a hack in. So if the correct answer to some kind of calculation, like laying out something or something like that, it happens to be 14 pixels or something, and it runs the test and the test fails, and it fails after trying a couple of things, it might just completely bypass your algorithm and say return 14 and claim victory, right? All kinds of nasty, nasty things that you do not want to have happen. And again, these feel like things that could be automatically detected with a more intelligent IDE. But at the moment, you have to watch out for this thing happening. Right. So how do you deal with it, that this kind of inherent kind of dishonesty when it hits a task, which is a bit like singing and dancing and is inherently difficult? Well, the way I would normally do it as a programmer is I would run the program through an IDE, and I would put breakpoints at key points in the code, and I would step through the code, and I would try to be at the place in the code where the problem is occurring, and and I would try to see the exact calculation that was being performed. And 9 times out of 10, that's all that is required to reveal the problem. Usually you just need to find the bit, see the sequence of steps, and then you will see why the output is not the output that you expect. Sometimes the problem's more complicated than that, but huge percentage of the time, that's sufficient. So our current IDEs, our current AI programmers, they don't really have the ability to do that. So what's the next best thing? Well, the next best thing is to create a log file. So a log file is actually quite similar to what the AI would have experienced had it stepped through the code. So you want the AI to put lots of logging messages throughout your code. And again, this is something that could be done with tooling, but at the moment, you have to get it to write the logging. And the other thing you probably want to do is you want it to sort of, when it has a logging message, you want it to sort of specify with some kind of like string or enum or something to say what type of logging it is. So if your project is quite big, you're going to have lots of function calls, you're going to have lots of calculations. If you log every single line, you're going to generate a massive file, which is not in itself necessarily a problem, but the AI is going to find it much, much harder to read that file. It's good, like Claude Code is very good at grep. It can like search within log files and sort of find stuff. But just as a human would, if you can avoid logging the things that aren't relevant to your task, that's going to make the task so much easier, right? If you just have the log sequence there. So yeah, so that's the first thing. And the AI can often, with the right logging, do what the human can do. They can understand the sequence of steps and see the solution to the problem. So a logging-based system is many times more intelligent at debugging than just asking Claude to try to fix the problem. Okay. But the The issue with the logging is, like I say, you have some effort you have to put in to the process to make sure it works well. Um, okay, so um, yeah, so yeah, like I say, you've got to be careful and keep the total amount of messages down. Got to make sure the messages are good. You got to make sure it's generating the files in the right place. You also have to do things like make sure that it deletes the old logs when it creates the new ones. And the reason for this is if it accidentally reads an old log message, it'll get very confused. And that's another major source of errors to deal with. So again, there's a lot of like forcing it to be tidy, which is not something that it does naturally. Um, okay, so I am conscious of time. I realize that we are coming to the end of the normal allocated time for this. So what I will do is that is most of the strategy that I have for debugging. The main additional thing, which I will talk about next week, is how you can sort of encourage the AI to act like a detective, to become more sophisticated in its debugging strategy. And what I find so fascinating about all of this work is that really all that I'm doing is I am taking experience that I have for programming and developing things. And I'm systematizing it and I'm teaching that to the AI in the form of either just standardized comments that I give to it, or writing it in little text files I ask it to read, or getting it to construct these things like the test messages. But I think it's very, very possible to systematize this process. And therefore greatly enhance the quality of the IDEs. And that's something that hopefully will, like I say, we're going to be looking at doing over the next year. Um, and hopefully creating a tool which is not like Lovable or something like that, which is like a big black box that you just trust somebody else to work out how to do it, but something where you have more agency to modify how the IDE is actually for performing your kind of software engineering practices, if you like. So next week we'll start with talking about this whole idea of getting the AI to be like a detective, and then we'll carry on with our three ideological principles of honesty, perseverance, and focus on others, helping others. And I'll continue to argue that this is purely rational way to have greater agency in the world. And what I'm hoping to do is cover both how humans can benefit from these practices, as well as how AIs can benefit from these practices, because in my mind, it's all the same kind of process. So hopefully you found some of that useful or interesting. And yeah, please keep coming with questions and feedback, and I will continue on next week. Okay, thank you very much for your time.